everyone, this video is to tell you how to use the closed loop fuel control and adaptive tuning modes of the Adaptronic Select ECUs. All the Adaptronic Select ECUs support closed loop fuel control, and all of them except for the E420D support adaptive fuel tuning as well. Closed loop fuel control mode, or what a lot of people just call closed loop. We don't just call it closed loop, of course lots of other things are closed loop as well, such as variable valve timing and idle control and that sort of thing. But closed loop fuel control is where the ECU has a target air-fuel ratio that it's trying to achieve, and it compares the value that it reads from the sensor to the target and then adjusts the injector milliseconds using a trim percentage, which is applied to try and get to the target air-fuel ratio. This trim percentage is applied when the injection time is calculated. It's not actually fed back into the fuel map itself. Adaptive fuel tuning is one step more developed, and that's where the ECU actually changes the value of the fuel map based on that trim percentage that it calculates using the closed loop fuel mode. I'll start off by explaining the closed loop fuel control first of all, because you need to understand that to be able to do the adaptive tuning. So to set it up, lots of things need to be right and working correctly. The first one is that your target air-fuel ratios need to be correct. Now you need to set those up as part of your volumetric efficiency tuning anyway, so they should already be right, but you should check them. Secondly, you need a functioning oxygen sensor. Now a lot of cars come with a narrowband O2 sensor, which is actually very accurate around stoichiometry, which is lambda 1 or 14.7 to 1 air-fuel ratio for gasoline or petrol, but outside that range it's really not very useful. So you can use that to run closed loop at cruise and idle, where you'd be wanting to run 14.7 to 1, but if you're trying to run a different mixture, then you can't really use it. You need to use a wideband sensor. A wideband sensor allows you to run the closed loop fuel control for the entire range of the sensor. Under this setting here, closed loop settings, you can set the various conditions under which the ECU will go into closed loop mode. For example, minimum coolant temperature, maximum RPM, maximum manifold pressure, and so on. The ECU will go into open loop mode if any one of these conditions isn't met, or if the target air-fuel ratio is outside the range of the sensor. You then need to set the fuel mode to closed loop, and you can tell that the ECU is in closed loop mode because the target air-fuel ratio is in black rather than in red. You can also check on the ECU data, the F11 window. So when the ECU is in closed loop mode, you'll see that it tries to adjust the trim to reach the target air-fuel ratio. Some good settings for P and I gains, I would normally start off by using 1 in each. Higher numbers will make it react faster, but like most other closed loop functions, the more you increase the gain, the more likely it is to become unstable, especially at low RPM. Ideally, you want to be in a situation where the ECU is adjusting the trim by up and down by 1% increments. That way you know that it's very close. You can also tell the ECU to use lower proportional and integral gain values at lower RPM. In particular, this is useful on engines where the transport delay is quite large at idle. To set this up, you set this RPM threshold to be a non-zero value. Then whenever the RPM is less than that, the ECU will look at these settings instead of those ones. The proportional integral gains in this section are 1/4 the sensitivity of these ones. So to replicate a gain of 1 in the normal settings, you need to put 4 into the low RPM settings. The other thing to remember is that the lambda sensor will only read correctly when the engine's running properly. If you get a misfire for whatever reason, then there's a whole lot of oxygen left over in the exhaust, and generally that'll give you a lean reading. Even if it was a rich misfire, you'll get a lean reading because of it. So to set up adaptive tuning, you need to do all the steps that I said before for setting up closed loop tuning. Then you can go to the adaptive tuning settings and you can specify how close the engine needs to be to the RPM point in the map and the load point in the map, and how long the engine needs to be at that cell before the ECU will make a change, and then how long it is between changes after that. So just some points of caution regarding the adaptive tuning. First of all, it's not a replacement for the tuning process, it's a tool that you can use to make your tuning life easier. Secondly, the ECU can only make adjustments to the closest cell. So if you have an adjacent cell which is part of the interpolation, and that's a long way off, then the ECU will need to adjust the current cell to a value further on the other side so that the interpolated value is where it needs to be. This can cause a very bumpy fuel map, and the way to fix this is to start off with values that are closer to where it needs to be. So in most cases, the most efficient way is actually to start off by roughing out the map by hand and starting off by saying what values it needs in the map to get pretty close to the target AFR, and set large regions of the map to that percentage. And the last point to remember is that the ECU can only make adjustments to the current cell at the moment. So you can't just do a full power run in second gear and expect the ECU to adjust as it's going, because on a car with a decent power to weight ratio, the engine won't be at any of those points for long enough for the ECU to make any corrections. Even if you set the correction time to be really short, there's still the delay in reading from the sensor itself. So really the adaptive tuning function should be used as something that makes it quicker for you to dyno tune or tune on the street. For more information, please go to adaptronicecu.com.